One more thing about proofs that we haven't covered is a strategy about what to do or how to handle when you've got a proof in which you're unable to fill out all of the truth values for each letter statement on the square. So I'll show you one like this. Let's look at it the same way we normally do. We have some, and then we have are not. We have therefore, it is false that, no, are. Okay, and be careful of the are not non. Here we're breaking our convention of using S and P or avoiding the use of S and P because they're making it kind of difficult. You can still use X and Y if you want to. I'm just going to go ahead and call people who recognize paranormal events P. These two terms are the same, but look, we have scientists S and non-scientists, which would be non-S. I just want to remind you that when you see an are not non, it doesn't cancel itself out. It's not a double negative, so to speak. Non-S is a term, and are not non-S is not equal to are S or something like that. I don't know why people get confused with that, but just to let you know, that's not how it works. That non-S is a term all on its own. So if we look at the standard form, some P are not non-S, therefore, don't forget to draw that line. It is false that no S are P. And if you start the proof, as always, with the premise, some P are not non-S given, and you go to the square, as we normally do. And you say, okay, well, some P are not non-S, that's an O statement, right? And knowing that it's an O statement, I know that the O on my square is going to be true. So I put that there. Okay, here's my given truth value. And I say, okay, well, the easiest relationship to figure out on the square is between O and A with what I've got right now. And that's the contradictory relationship. So if O is true, then A is false. But falsity does not flow downward with subalternation, and truth does not flow upward on this side of this, on these two sides of the square either. So I can't use subalternation to get the truth values for I and E. And guess what? The contrary relationship that connects A and E, its required condition is that at least one of them is false. Well, that required condition is already met. A is false. And on the bottom of the square, the relationship between I and O, known as a subcontrary relationship, the requirement or rule is that at least one has to be true. That requirement has already been met. So truthfully, we cannot put any truth value at all, because it was a funny way to say it, but realistically, or it would be impossible to do this, we don't have any truth values for E and I. And that can look really scary when you're working a proof. You're working through like normal and you hit this snag and you say, oh, what am I supposed to do with this? But actually, it's a good thing, because if you don't know the truth value for that particular letter statement, you can't use it. So you've basically eliminated half of your choices to begin with. So don't worry when you see something like this. Now we're going from a true premise to a false conclusion in this particular example. So we don't want to go anywhere that's true. So we don't want to use the O. So it becomes clear that we want to use the A statement. We'll change it here, adding an it is false that we're going to carry down for the rest of the proof. Change this to an A statement, leaves the terms alone. How did I get from O to A? That is the contradictory relationship. You can also put contradiction if you want. Okay. But we still need to figure out how to get this all to no, this non-S to S. So let's use obversion first. So it becomes no R, that non-S becomes S, and the P stays the same. Then all we need to do is use conversion to switch them. All right, so now we've got no S or P in our work, or it is false that no S or P in our work, and it is false that no S or P in our conclusion. So we have proved this argument. And that's how to deal with a traditional square of opposition, or a proof in which your traditional square of opposition is where you're not able to find the truth values for each one of the letter statements.